Continuation of previous topic, the same topic, Nyquist stability criterion. The Nyquist, we are dealing with the Nyquist contours for defined enclosures, all the right half of S planes zeros and poles of Q of S, that is 1 plus G of S into H of S. Let there be Z zeros and P poles of Q of S in the right half of S plane. As S moves along the Nyquist contour in the S plane, a closed contour TQ is traversed in the QS plane, which encloses the origin, that is represented by, that may be in a counterclockwise directions, as we studied in the previous sections. So closed contour tau Q is traversed in the QS plane, which encloses the origin. N is equal to P minus Z times in the counterclockwise directions. For the system to be stable, there should be no zeros of Q of S is equal to 1 plus G of S into H of S in the right half of S plane. That is, Z should be equal to 0. This condition is met if N is equal to P. There should not be any zero. That is, for a closed loop system to be stable, the number of counterclockwise encirclement of the origin of Q of S plane by the contour tau Q should equal to the number of the right half S plane poles of Q of S, which are the poles of the open loop transfer function G of S into H of S. We come across this pole is same as the open loop this open loop transfer function G of S into H of S. This pole is same as for your Q of S pole. Okay. Now number of, I'll come there, wait, should equal to the number of right half of S plane poles of the QS, which are the poles of the open loop transfer function G of S into H of S. Later. So here, for open loop stable system, if you're taking an open loop stable system, I told later, that is P is equal to 0. So for open loop stable system, there should not be any poles on the right half of S plane also. And the closed loop system is stable if N is equal to P is equal to 0. Now, if open loop system is the open loop system, if the open loop system, that means open loop system is nothing but the loop gain. Regarding the loop gain, in order to be open loop should be a stable system, then there should not be any pole on the right half of S plane. Okay, and that is the condition for open loop. Now closed loop, for a closed loop system, when this condition is satisfied, that means open loop system is used to construct a closed loop. Open loop stable system is used to construct a closed loop stable system. Then N is equal to P is equal to 0. For a closed loop system, the minimum condition is there should not be any zero on the right half of S plane of its characteristic equation, that is 1 plus H of S into G of S, that is Q of S. In that case, you can have N is equal to P. that means the contour counterclockwise rotation around the origin of Q of S plane by tau Q contour is equal to n is equal to P. But for an open loop stable system, P should be 0. But if open loop system is not stable, but there may be a chance to become closed loop system stable, that is also happening. So a perfectly stable system, you can say that n is equal to P is equal to 0, which means that net encirclement of the origin of Q of S plane by the tau Q contour should be 0. So it is easily observed that, again we are analyzing, it is easily observed that G of S into H of S, that is open loop of loop gain, is equal to 1 plus G of S into H of S minus 1. So it therefore follows that the contour of G of GH, that means loop or open loop transfer function G of S into H of S corresponding to the Nyquist contour in the S plane, how this open loop transfer function contour is, how it is related to Nyquist contour in the S plane is the same as the contour TQ of 1 plus G of S into H of S, the contour TQ of 1 plus G of S H of S drawn from the point minus 1 plus J0. Thus the encirclement of the origin by the contour TQ is equivalent to the encirclement of point minus 1 plus J0 by the contour tau H as shown in figure 1. So what you can do here is, so tau Q is nothing but it is a closed loop contour, closed loop function, that is Q of S is 1 plus G of S into H of S, that contour. So in order to, there is no need to do this. Instead of that, by considering this open loop transfer function G of S into H of S is nothing but 1 plus G of S into H of S minus 1. So here, instead of doing 1 plus G of S of H of S, we can use tau of G of H instead of tau of Q. So how you are getting tau of G of H? It is nothing but just contour is drawn from a point minus 1 plus J0. Okay. Thus the encirclement of the origin by the contour tau Q is equivalent to the encirclement of the point minus 1 J0 by the contour tau GH. So the both are same. You can either using 1 plus G of H contour or simply a G of H contour. The G of H's contour is obtained by just shifting this to the left, and it is related to a point minus 1 plus J0. So you should see that whether the G of H contour should encircle the minus 1 plus J0 point. If you are using tau Q, then or 1 plus GS contour, in that case it should rotate the origin, perfect origin. But if you are taking only open loop transfer function, then that should be encircle minus 1 plus J0. So that is the main point you should remember. Now, the Nyquist stability criterion may be stated as follows. I think that you understood this because of this expressions. So whatever the contour obtained by, it is shifted -1, then you are getting the contour of this. So instead of doing this, you can directly do this with respect to -1 point J0 point. That's only. Now next, Nyquist stability criterion may now be stated as follows. If the contour tau GH, I think it is tau, I don't know, this symbols pronunciation, I have to see that. Presently we will take it as tau, but later you can change it. The contour tau GH of the open loop transfer function G of s H of s corresponding to the Nyquist contour in the S plane encircles the point -1 plus J0 in the counterclockwise direction as many times as number of right half of S plane poles of G of s and H of s. The closed loop system is stable. So this is very easily you can understand that both are here, this and this both are same Nyquist. This is for the Nyquist plot of 1 plus G of s and H of s. This is the plot of G of s into H of s. So here, if the contour tau GH of the open loop transfer function, that is dotted G of s into H of s, correspond to the Nyquist. It is same as Nyquist contour in the S plane encircles the point -1 J0 in the counterclockwise directions as many times as the number of right half of S plane poles of G of s H of s. If it encircles, okay, I think that in encircles in a counterclockwise directions. Okay, so counterclockwise directions as many time as the number of right half of S planes of G of s H of s, but the closed loop system is stable. So the closed loop system is stable. You know that it is stable when there should not be any right hand zeros of 1 plus G of s into H of s exist. But if there are poles on the right half of S plane, then it is stable. Okay. In the commonly occurring case of open loop stable system, in the commonly occurring case of open loop stable system, here we don't know whether it is open loops. Yeah. So you will see in the commonly occurring case of open loop stable system, the closed loop system is stable if the contour tau GH of G of s H of s does not encircle -1 plus J0 point. That is, the net encirclement is 0. Here, there are two conditions are there. In the first condition, the contour tau GH encircles -1, 0 in a number of times that is equal to number of poles on the right half of S plane of this open loop transfer functions. Okay, open loop, that means loop gain. Then the open loop may not be open loop, that is not stable, but closed loop is stable. But if open loop is stable, then there should not be any pole. There should not be any pole of open loop system should be on the right half of S plane. In that case, the contour tau GH of G of s HS does not encircle -1 plus J0 point. That is, the net encirclement is 0. So there won't be any encirclements. Okay. Now the mapping of the Nyquist contour into contour tau gh is carried out as follows. The mapping of imaginary axis is carried out by substituting of S is to j omega in g of s into h of s. We have to substitute j omega in g of s and h of g of s into h of s, where s is equal to j omega. You have to substitute. This converts the mapping function into frequency function of g j omega h j omega. First you have to change s to j omega. Then physical system. In a physical system where m is less than or equal to n, m is less than or equal to n, that means number of poles is number of zeros is less than or equal to number of poles. In that case, limit s is tending to r into the power of j pi or r tending to infinity, g of s into h of s is equal to a real constant, and it is 0 if m less than 1, m less than n. It is the encirclements may be real constant, and it is 0 if m less than n. So thus the infinite arc of the Nyquist contour maps into point on the real axis. Thus the infinite arc of the Nyquist contour maps into a point on the real axis. So here, as you know that limit s tending to r into e to the power of j theta r. So here we come across that number of zeros should be less than or equal to number of poles. In physical system, number of zeros is less than or equal to number of n. So when you're observing it, you can see that limit s tending to r into e to the power of j theta, r tending to infinity, g of s into h of s is equal to a real constant, and for m less than or equal to n, and it is 0 if m less than n. Thus the infinite arc of Nyquist contour maps into a point on the real axis. So that is why it is a real constant. So the infinite arc of the Nyquist contour maps into a point on the real axis. So it will be understood when you are doing the problem. So okay, the complete contour tau gh is thus the polar plot of g j omega h j omega, with omega varying from minus infinity to infinity. This is usually called the Nyquist plot or locus of g of s into h of s. The Nyquist plot is symmetrical about the real axis, since g complex conjugate or g star j omega h star j omega is equal to g minus j omega h minus j omega. So from this you can see that it is symmetrical about the symmetrical Nyquist plot is symmetrical about the real axis. So try to understand this. So this you can understand when we are doing the problem. So go through this 2 times and try to understand. If you are not still understanding, go through it 2 to 3 times. Okay, so try to understand it properly.